Of course, I'd be happy to help you assess your current level and then guide you forward step by step. Let's start with a quick assessment question. Here we go. Can you explain what happens during the training phase of a simple machine learning model, like linear regression?
So in training phase, basically what we do is split the dataset into training and testing, and we train the machine learning on a training dataset, and we take our training accuracy score.
Good attempt. You're starting with the idea of splitting the dataset, which is important. Now let's build from that. During training, the model also adjusts its internal parameters, like weights, to minimize the error. Let me ask a follow-up. Can you describe how a loss function helps guide that adjustment during training?
So basically a loss function like a sigmoid function. Are you asking about that?
You're on the right track thinking about the role of a function. The loss function measures how far off the model's predictions are from the actual values. The sigmoid function is often used as an activation function, especially in classification. But the loss function itself is what we minimize during training. For linear regression, an example would be mean squared error. Does that help? What kind of model are you picturing right now? Classification or regression?
Oh, thank you for clearing it out. I got really confused between those two functions.
You're doing great, and it's completely normal to feel confused at first. It takes time to sort out these concepts. Let's break it down further. Imagine we're working with a simple linear regression model. We have input features, and we want to predict an output. Now, can you think of a real-world example where you might use linear regression? Maybe predicting house prices based on size?
I can think of an example of a stock market.
That's a great example. Predicting stock prices based on past data can be a perfect scenario for regression. Let's dive deeper. In this case, the features might be things like previous price, trading volume, or some indicator. The model tries to find the best fitting line. Now, can you think of one or two features you might use to predict a stock's price tomorrow?
Let's just say we can say a feature of the volume of a stock and the price of the stock which was today.
Excellent. Those are solid features to consider. Today's price and the volume. Let's go step by step. The model takes those features, applies weights, and then predicts tomorrow's price. Now, how do you think the model learns the right weights during training?
So, like, we use the training dataset.
Exactly. We use the training dataset. The model makes predictions on it, then compares those predictions to the actual values. That's where the loss function comes in. It measures the difference. Then, the model adjusts the weights to reduce that loss, step by step. Does that process make sense so far?
Yes, it makes sense.
Great to hear that. Now let's go one step deeper. Think about the model adjusting those weights. It uses a process called gradient descent. This is like walking downhill, step by step, to find the lowest point of the loss function. Can you tell me what direction the model moves the weights in each step?
I really have no idea about this concept. Can you please explain me that?
Of course. I'm glad you asked. Let's break it down step by step. When the model sees how far off it is, that's the loss. It also calculates the slope, or gradient of that loss. The gradient points in the direction where the loss increases. So, to reduce the loss, the model updates the weights in the opposite direction. It's like stepping down a hill, always trying to go lower. Each small step improves the weights a bit, and after many steps, the model gets closer to the best solution. Does that clarify how the weights are adjusted?
Okay, thank you. I got the concept perfectly.
I'm really glad to hear that. You're making great progress. Now let's do a quick check. If the model's predictions are too high,